This will probably be the last of the demo videos because there are only 2 left. The Round Robin dataset 1 is interesting, but I will not spend much time on that. You can test that yourself. This Round Robin experiment was one where we sent around 4 datasets of different kinds of particles. And these were the particles that we had, right? So dataset 1 was for a bimodal gold nanoparticle dispersion. Then we had a silica nanoparticle dispersion that was measured at the PTB. Then we have a bimodal silica powder that was measured on our instrument, and a nanodiamond powders. And these nanodiamonds were created using an explosive process, so they're very irregularly shaped. You can read more about the data analysis round robin if you follow this link. I think it was a really interesting experiment, but these are some of the data sets for that. The interesting thing about this data set is that it's actually bimodal, but it's very hard to see that it's bimodal because one of the populations was pretty much half the size of the other population and only present at 10%. So that was an interesting one. But I actually want to show you data set number 3 because that one is kind of tricky, right? You see this data set, it's got 2 populations of silica in it, and if you look at the electron micrograph, you'll actually see these 2 are different by about a factor of 10, right? So we have really, really small particles, and then we have particles that are 10 times bigger. And this is packed into a powder. So these elements, these components, they intercalate. And they create these structure factor effects in there. Quite prominent structure factors. So the data settings are, whoops, did I do that correctly? Yes, sorry. The data settings are, again, they were reading CSV files. These round robin data sets were with CSV files. We've now changed the separator from the semicolon we had in our quick start demo to a blank space separator. It's a generic blank space separator. We again don't have a header, and we want to name the 3 columns Q, I, and I sigma so that McSAS knows which one is which. We're clipping the data range, and we haven't cheated with our minimum uncertainty estimate. This is now 1%. So this is pretty much, yeah, the read-in is not very hard. I can spend a couple more words on that, but I don't think it's absolutely necessary. So the model that we have for this has been modified a bit because it's kind of hard to fit this. You can try it if you want. So what I've used here is a sphere with a hard sphere structure factor because we have a structure factor, massive one over there. I've increased the number of contributions. It's not absolutely necessary. You can keep it at the default 300 if you want. It will just take a little bit longer to optimize. Again, we have custom fit parameter limits because we do have some scattering from larger objects over there. And we have a structure factor. So in order to get this little bit right, we need to extend the large size a little bit, right? So normally based on these Q limits, I think the maximum dimension, maximum radius would be about 200 something nanometers. And I've now increased it to 314. So don't go overboard with this because the information is not really present in your data. But in order to correctly model these first few data points with this model, we need that. I haven't actually changed any of these. So those are the defaults, so the volume fractions will be wrong. And you will see that for the structure factor volume fraction, we've taken a relatively high volume fraction because, again, it's a prominent structure factor. Interesting to note that the maximum theoretical the maximum theoretical volume fraction for randomly packed powders is 0.67. So if you have randomly packed powders, you will never ever, or you should never ever have a volume fraction higher than 0.67. Yeah, maximum number of iterations, 50,000. Don't want to go overboard with this. But stop if you reach 5,000. It won't do that, but just to be on the safe side. And I have my random logarithmic number picker selected. So I can test that one. You can see that it will actually work within a reasonable amount of time. And that fits the data quite perfectly. I wouldn't show it otherwise. So I just want to run that optimization on the third round robin dataset. It will take a little bit longer than the test optimization because now we have 10 of these processes, most of which are running in parallel depending on how many cores you have on your machine. The histogramming has been modified a little bit because we want to isolate the individual populations. So when I show you the histograms, you will actually see that, yeah, we've managed to fit that data, of course. The total size distribution shows 3 populations, actually, something small. That is probably the cause for this sort of slow upturn or background or whatever. That usually ends up at small sizes. We then have a population in the middle. That is those are our small particles, and then we have a population a decade above that. So when we look at those individual populations, then we see that the small population is about 11.3 nanometers in radius, in mean radius, and the large population has a mean radius of about 136 nanometers. Don't put too much reliance on the outer data points. As we mentioned before, we've actually extended this range a little bit just to get that slope at low Q correct. But that is that particular example. I highly recommend playing around with this. You can also play around with the run settings. You can actually change the volume fraction a little bit from between 0.5 and 0.6, and you can see how that affects the resulting size distribution. Remember, whenever you change one of these things, that you save the configuration into one run config, and that will then be automatically set in your optimization tab. So yeah, that's all for this video. Please do play around. I will have probably a couple more videos to explain the back end a little bit, the HDF5 structure, the information that you can find there, and the way that McSAS actually optimizes. So do check out those videos, and please feel free to contact me in case of any questions. So yeah, good luck and have fun.